So in the previous video, we factored two-term polynomials. We also did three-term polynomials where a is equal to 1. We're now going to do when a is not equal to 1. So we're going to use the slip and divide method for this. Example number 1 is 4x squared minus 15x plus 9. This is how the slip and divide method works. First, you're going to slip the a term to the c term. So you're just going to multiply. So x squared minus 15x plus 36 now, because 4 times 9 is 36. So now you have your a value is 1. So you would factor this normally. The factors of c that add up to b. So 12 and negative 3 would be those factors. So you can see now that I'm writing x minus 12 and x plus 3 as the factors for x squared minus 15x plus 36. And then now you're going to do the divide step. So in the beginning, you slipped the 4 to the 9. So you did 4 times 9. Now you're going to have to divide by 4. So in the beginning, you get to slip the a value, and then you will have to divide by the a value. So x minus 12 over 4 is x minus 3. And then x plus 3 over 4. 3 over 4 does not divide evenly. So I'm going to put the 4 in front of the x. So we have 4x plus 3. And that's our final answer. X minus 3 times 4x plus 3. Okay, example 2. We are still factoring when a is not equal to 1. So we have 12x squared plus 13x minus 4. So the a value is 12 here. So you're going to use the slip and divide method again. So first we're going to slip the 12 to the negative 4. So that means we are multiplying 12 times negative 4. So we're going to get x squared plus 13x minus 48. Now, a is 1 in this case, in the purple polynomial here. So we are just going to factor that normally. We're looking for two numbers that multiply to negative 48, but when you add them, you get positive 13. So those numbers are negative 3 and positive 16. Now you're going to factor this as x minus 3 and x plus 16. Okay, don't forget to divide now by the 12 that you slipped in the beginning. So x minus 3 over 12, well, we can reduce 3 over 12 to 1/4. So we have x minus 1/4. And then x plus 16 over 12, well, 16 over 12 can reduce to 4 over 3. So we have x plus 4 over 3. And then lastly, we don't want to leave fractions here. So we're going to slip that denominator to the front of the factor. So we get 4x minus 1 and 3x plus 4 as our final answers. Done. Okay, so now we're going to work on 4-term polynomials. So for 4-term polynomials, you're going to use the grouping method. So in this method, you're going to create two groups and then factor out their GCF of each group. And your final answer is going to be the GCFs in one parentheses and the twins in another parentheses. So watch to see what happens. We have example 1 here. We're going to be doing 8m to the third power plus 32m squared minus 8m minus 32. Okay, I have a couple of options here. I noticed that there's like repetitive coefficients. So I have two 8s as my coefficients. Well, a positive 8 and a negative 8. And then I also have a positive 32 and a negative 32. So I thought to myself, let me rewrite the problem. Of course, I could just put the groups now, but I'm just noticing numbers that or terms that kind of go together better. So I'm going to rewrite it as 8m to the third minus 8m. And then I'll do the 32m squared minus 32. Again, you don't have to do this all of the time, but sometimes it's helpful. So, in the first group, we're just going to put parentheses around the first two terms. So you're going to create two groups. Since we have 4 terms here, you're going to put the first 2 terms in a group, and then you're going to put the second 2 terms in a group. So you can see here that I'm just going to color coordinate to help you kind of see what I'm doing. So I put the first 2 terms in a green group, and then I put the second 2 terms in a blue group. So now I'm going to find the GCF of the green group, which is 8m. And then what would be remaining is m squared minus 1. The GCF of the blue group is what I'm doing next. So that's going to be 32, positive 32. And then what's remaining in that group would be m squared minus 1 as well. So hopefully now you can see what I was talking about earlier when I mentioned twins. So in your final answer, you're going to put the 2 GCFs together in one set of parentheses, and then you are going to write the common factor in another set of parentheses. And the common factor is what I like to call the twins. So that would be m squared minus 1. And there goes your final answer, 8m plus 32 times m squared minus 1. So just reminding you again, like I said, the GCFs will be your first set of parentheses, and then the twins would be your second set of parentheses. Okay, let's go ahead and start with example number 2. Let me just move this up a little so I have space. Okay, that will work. Okay, so example number 2, we're going to be doing 7a to the 3rd power plus 2a squared plus 42a plus 12. Okay, again, we are doing the grouping method because there are 4 terms in this problem. Okay, so you can see that I put the first 2 terms in a group and the second 2 terms in a group. So in the blue group, the GCF is just a to the 2nd power because 7 and 2 don't have a greatest common factor. But I can factor out a squared, leaving me with 7a plus 2 in that group. And then in the green group, the GCF of 42a and 12 would be 6. Leaving me with 7a plus 2 in that group as well. And now you can see, again, you will have that common factor that I like to call the twins. So in your final answer, you're going to group together the GCFs. So that's a squared plus 6. And then the second group is the twins, or the common factor 7a plus 2. Done.